Alright guys, this is going to be a short sweet video because this is just about the ability to use a formula. I would love if you understood how these formulas work, but it's mostly, I'm not going to take away your notes. Even when we were in person, you got a formula for this stuff. So it's just realizing that these formulas work in radians. If theta is a central angle in a circle measured in radians with a radius of r, okay, r stands for the radius, the length of the intercepted arc, so S is arc length. Then the formula, the relationship between these is just S equals R times theta. So 1 radian with a radius of 1 would give you 1 arc length. Okay, but the relationship is here. So I'm going to do a grand total of 2 examples here. One where they give us the radians. So here theta is already in radians, and they give us a radius of 3. We are to measure the intercepted arc S, and it wants the answer in terms of pi and rounded to the nearest tenth. So in terms of pi, it's already in radians, okay? Has to be in radians. This one is in radians, so we're going to put 3 feet times 5 pi over 6 radians. Now, remember I told you in the last video that radians are magical? The label can appear and disappear. Well, here when you multiply feet by radians, you just get feet. It's kind of magical. Now, 3 times 5 is 15, divided by 6 will reduce to 5 pi over 2. You could do it on your calculator. 3 times 5 divided by 6, math, enter, enter. Okay, but don't lose the pi. So this is now feet, and then they want to know what that is as a decimal. 5 times pi, there it is, divided by 2. The decimal is 7 point, what did they say, tenths? So 7.9 feet. So you are to answer in terms of pi and as a decimal. That's it. It's r times theta. Reduce it. Okay. So I'm not going to do another example given radians. I mean, I could, it wouldn't matter here. 3 pi over 2 times a radius of 0.5 yards. If you multiplied that, would become 3 pi over 4. I'll show you. You would type 3 divided by 2 times 0.5. Math, enter, enter. And you'd get 3/4, and then you still have the pi that we didn't type in. And then the second part of the question is they want the decimal, so then you'd say I need to take and actually type the pi in there. And I get 2.3 or 2.4. All right, so I did 2 even though I said I wasn't going to. Now, when you get to the ones where they give you degrees, you have to change it to radians. So remember, it's pi radians are equal to 180 degrees, so then your degrees cancel out. So you have 15 pi over 180, which does reduce, but I don't care because I want to multiply theta times r. Now, they do want an exact answer, and usually exact doesn't include decimals along with irrational numbers like pi. So we're going to go 15 divided by 180 times 8.4 and then change it to a fraction, not a decimal. So 7, what does that say? 7/10? Okay. And then go ahead and multiply it by pi to get the decimal, 2.2. So this all reduced to 7 pi over 10 radians, nope, kidding, meters, or 2.2 meters. Okay, so if you were going to do another one, pick any one here, and you would multiply by pi over 180, and then times 1.8, and your answer would be in feet. The exact one, though, you would need 120 divided by 180 times 1.8. Don't put the pi in. Math, enter, enter, is 6/5. And then you can type the pi in and get a decimal, okay? So this is 6 pi over 5, which is approximately some decimal, and I'm not going to do it. Okay. Number 9 has you working backwards. Same thing. Remember, arc length equals radius times angle in radians. So the central angle theta in a circle of radius 6 has an intercepted arc, that's S of 10. Find the measure of the angle in radians and degrees. Well, this formula is automatically in radians. So if we just have 10 equals 6 theta, we divide, and we get 5/3 equals theta. That is in radians. I know there's no pi, and that's bothersome, but it already is in radians. If you want to change it to degrees, it's in radians, so you're going to put pi to get rid of the radians, which there's not a pi to divide out, and then up here goes 180 degrees. I know that's confusing because there's no pi, but there doesn't have to be. So it would be, where's my calculator? 5/3 times 180 over pi. And you could use parentheses in there. You could even type the top and then divide by the bottom, but you'd need the bottom in parentheses, that 3 pi. You could have reduced ahead of time. Lots of ways you could have typed that in. But if you're typing it correctly, it will come out 95.5 degrees. All right. I'm going to skip 10 and let you guys do that one. One more of these. It says we have 2 cities. Let's pretend this is the Earth here. This is the center of the Earth, okay? And on the edge of the Earth sit these 2 cities. One is at a latitude of 39.1 degrees, and one is at a latitude of 33.7 degrees. So we'll say north of the equator was down here, the equator. This one was north 33.7. This one was north 39.1. So the angle in between here is the difference in those in degrees. That's why I didn't give you this one, because it's kind of tricky. Did I type that right? Oh, my 7 didn't work. There we go. 5.4 degrees. And the radius of the Earth, they're saying, is 3,960 miles. So how far apart are the cities is our S, our arc length. But we can't use the formula S equals R theta until we have radians. So the radius is 3,960 miles. But the angle is 5.4 degrees times pi over 180, so that the degrees will cancel out. Then we can just type it all in. So 3960 times 5.4 times pi divided by 180. 373.2 miles apart. Okay. Then there is a formula for area of a sector. Now you actually learned an area of a sector formula in geometry, but that was given degrees. This area of a sector works when theta is radians. And the formula is 1/2 r squared s. Nope, just kidding. 1/2 r squared theta. What am I doing? My brain. Sorry. 1/2 r squared theta. Or 1/2 theta times radius squared, or r squared times theta divided by 2, etc. Okay? All kinds of different ways you could write it. So, the thing is, again, radians is the only way this works. So to do this number 13, it looks like I wanted to do with you, you can't have 205 degrees. We're trying to find all of the area within this shaded area. So you have to take 205 degrees and change it to radians. Okay? I'm not even going to bother to mess with it because I want to use it in the formula anyway. So this is our theta now. So the formula is 1/2 r squared times theta, which is now in radians. So we have 0.5 times 11.2, which you got to remember to square that one, can't forget, times 205 pi over 180. You can reduce that, but it doesn't matter, it's going in my calculator anyway. It is 224, was it 0.0? 0.4? And that is feet squared, because it's area, and because that's what I did. I squared the feet. Again, radians just goes away. All right, let's try one more. And then we're going to do one where you work it backwards. This one's actually even easier. Theta is already in radians. 19 pi over 12 is already in radians. So the formula is 1/2 r squared theta, or 1/2, which you could use 0.5. R squared is 23.6 squared. And then times theta, which is 19 pi over 12. They already gave it to us. So if I type that, 0.5 times 23.6 squared times 19 pi over 12. It's all multiplying and dividing. I don't even need any parentheses. You can use them if you want. But I got 1385.2. And the label was meters squared. All right, now I think we have to work one backwards. It says the area of a sector with a central angle of 240, which we're going to need to change to radians, is, the area is 134. Find the radius. Okay, so I'm going to put 134 equals, I'm just going to use 0.5 because we're going to have decimals everywhere anyway. And I'm going to actually write this as 0.5 times theta times r squared, because that'll let us do some calculations ahead of time. So I just change that in the order over here. So the theta is 240 pi over 180. And then we have an r squared. We can go ahead and do this as a decimal. It's not going to help us much either way. So it's 0.5 times 240 times pi divided by 180. So I have 2.094 over here. So it's 134 equals 2.094 r squared. So if I divide, I get r squared equals I'm just going to say divide by that last number there. And you get this, okay? Roughly 64. And what's the square root of 64, guys? 8 feet, okay? Now, I did that in my head. You can do it on the calculator here. Square root of that last answer. And it does round to 8. All right, I think we're done. Unless I put an extra one on here. Nope. All right, you are to go back and do numbers 2, 8, 10, 12, and 14. And then there's an activity on slide 9 that goes with this. That's it today. 2 formulas, easy peasy. Makes up for a long video yesterday.